I want to introduce entity trait systems. I couldn't find it online, so I think it's new, and I think it fulfills the same or nearly the same requirements as ECS, and it's easier to use. ECSs came about for games which have millions of entities. They have these diverse interactions where some entities will be looking at others, and they'll all be doing different things based on different properties that the entities have. And it needs to be fast and correct. So here I have two snippets. On the left is a fast way of doing things, but it's not correct. And on the right, we have a slow way of doing things, but it's correct. It's fast on the left because each entity is fully processed before moving on to the next one. So this is better on the cache. But it's incorrect because the previous domain of updating has not been completed before moving on to the next one. So you'll have things looking at other things, but it'll be one frame behind. But for the last update domain on the right, rendering and doing audio can happen at the same time because they're both just viewing the state from the previous domain. So some things can happen in that way, but others can't. Because there's a large number of entities, it would take too long to sequentially iterate through and update each of them. That's where parallelism comes in. You'll have some workers which can process each entity in the same type of way, and this can be distributed over the workers so the job gets done faster. This problem becomes harder when entities can look at each other, because then an entity can be modified at the same time it is read, and that will cause a race condition. Lastly, how do we do all of this while being safe and working with the borrow checker? So this snippet is something that I did a while ago where I was trying to solve the same sort of problem, and it turned very messy very quickly, and it was also very inefficient. So how do you do this, and how do you do it right? The first step to the solution is a generational arena, and there's better explanations on this online, but an arena is a pre-allocated area where all of the entities' lifetimes can be better managed together. So if the arena is deallocated, then all of the entities are deallocated at the same time. It can be thought of like a vector data structure, and if an entity needs to reference another entity, it'll do so with an index and a generation. So if a entity is deleted, then the cell becomes free instead of occupied, and then if a new entity is put in, then it'll have a different generation number. So if you're looking at an entity, you will go to that offset within the vector. You'll first check if the generation is correct. If it is not correct, then your entity that you're referencing has been removed from the game, and so you can't look at it anymore. Built on top of generational arenas are entity component systems. So an entity component system can be thought as a table where a entity ID or key is the row index into the table. So you have entity 0, 1, 2, and then each of the columns are the components that the entities have. So for an example, entity 0 here has both a position and a velocity components, but some of them could have the component or some of them could not. And the actual data structure that's being used to store each of the components can be decided on. So this shows it like a vector for each component, but you can choose a different data structure if your data is more sparse. So you could have some sort of sparse set instead of a vector. I don't like this because the data is just exposed. So the types of questions that you'll ask in a game are, if I were to damage an entity, how does it take damage? And then it will then be able to decide that through however it implements the damageable traits. But just having the data exposed like this means that you can't do that sort of thing. So that was entities and components. Next is system. System is a query which automatically applies to an entity component system. So in this case, it'll query for all entities that have a position and a velocity, and then it'll do some work on those entities. This can be implemented with a bit vector. So in the ECS table, it'll show what entities have those components. It'll do the AND between those two components, and that way it can figure out which indices have both components. These systems will be scheduled by the ECS, and it'll do borrow checking on each. So it'll check, do we have one writer to a system or multiple readers? And it'll schedule it in such a way that the systems which don't interfere with each other can run at the same time. So not only do you have parallelism between entities, you also have parallelism between systems where it's possible to do so. There's a newer form of ECS called an archetypal ECS. The Amethyst project decided to move to this instead, and I think Unity's ECS system is also based on archetypal ECSs. So if your entity has a position and a velocity component, and only those components, then it'll go into that archetype. And so at runtime, the system will query by going through every archetype, seeing which ones fulfill those properties, and then iterating through each entity in that archetype. The entity trait system does something similar, so it's important to keep this in mind. So those are the existing solutions, and here's the entity trait system. So to use it, it looks like a macro where you can state the name of the worlds, the entities which will be in the worlds, and also the traits which are queryable on those entities in the worlds. Each trait does not need to be implemented by each entity. You can pick and choose which ones will be implemented by which. This macro then generates arenas for each of the entity types. If you like to, you can access them directly, or you can access them by the type at compile time. And then you can visit all entities which implemented traits. You can do this in parallel or not in parallel, depending on if you have the rayon feature enabled. And what this will do is it visits, and everything's bound at compile time, each archetype which implements that trait. And it's important to know that this is all at compile time. Otherwise, if you did runtime dispatch per each entity, then this would be extremely slow. There's also a type erased API. So let's say you have a reference to something in the world, but you don't know specifically what type it is. Then you can work with that as well with a runtime arena ID. There's a handy command called cargo expand, which shows what's the output of the macro once it's been processed by Rust. And it shows exactly how it implements visiting each of the traits at compile time. This requires the nightly compiler because it relies on the specialization feature, which is unstable in the Rust language. It's being used in a very basic but necessary way, where it just checks if an entity implements a trait or does not implement a trait. This is required because Rust doesn't have C++'s style of templates, where you have substitution failure is not an error. I've exposed the dense slot map arena. I decided to go with this one because it allows for very fast parallelization, and all of the alive indices are kept in contiguous memory. I also looked at other types of slot maps or also the generational arena crate, but I felt that this was the best. Writing the macro was pretty hard. Certain things which you'd think are typically possible were not. So for example, if you have a double for loop over variables in Rust's macro system, the scope of the inner variable doesn't exist. So you can't do something simple like a double for loop. I understand why they did that. They probably wanted to limit the sort of things that you can do at the macro level, so that way you can't explode the number of symbols which are being worked with. But it really got in the way, and fortunately there was a way around it. And the size of the generated code is n times n, based on the number of entities and the number of traits. This is okay. If you have a large number of entities or traits, you could fall back to runtime dispatch and have it handle it underneath. Kind of like a polymorphic way of doing things. You have the compile time specializations, and then you can fall back to runtime if you really need to. In my opinion, the one tangible downside of this system is the fact that it can't do system level parallelism. So in the ECS, there's two levels of parallelism. There's parallelism between each entity within a system, and then each of the systems can also run at the same time. But to do that system level parallelism, you need to know what components are going to be read or written to at what times. And in order to access each of the individual components, those pieces of data need to be exposed. And that doesn't happen with this trait system. I don't think that this is too big of a deal because a lot of the speed up already is from iterating through all of the elements in parallel. And also, if you really need to, you can squash these subtraits into these bigger traits, which will then have those systems run in parallel. So there is a way around it if you need to. I haven't used this in a project yet, and although I've thought ahead on what could happen and I've tried to cover all the bases, there could be something that I'm missing. So I'm hoping that more people will take a look at this, and if there are any improvements that can be made, please let me know.